Hello, you are warmly welcome to today's video on differentiation calculus. So today we have to use Leibnitz theorem to find the fifth differential of e exponent 2x times cos 3x. So how do we even do that? So in order to begin, what we have to do is that we need to identify the different functions we have here. We have one function which is e exponent 2x multiplying another one that's cos 3x. So we begin by saying, let's let this is our solution. So this is not this is the fifth differential of e exponent 2x plus 3x. Okay, so let me write that here. Let u equal e exponent 2x, and let's also let v, let me write that here. Let's also let v equal plus 3x. So what we have to do is that, since we are finding the fifth differential, what we have to do is that we need to differentiate this and that 5 times. Okay. So in order to differentiate this 5 times, let's do that. Okay, so we have u1. So when we find u1, it means that we are differentiating u just one time. So whenever we try differentiating a function in e-less form like this, what we do is that we differentiate the exponent. So when we differentiate 2x, the answer is 2. Then we multiply that by 2 exponent, e exponent 2x like that. Then we find the second differential. That means we have to differentiate the first one we have here. So we do the same to differentiate the exponents 2x. That is when we differentiate 2x, we have 2. So 2 times 2 will be 4, e exponent 2x. Then to find the third differential, so we have to differentiate this one. We have to differentiate for the third time. So when we differentiate 2x, we have 2. So 2 times 4 gives us 8. So 8 e exponent 2x. Then we keep doing that. So we have to find the fourth differential. Let me do that this way. And when we find the fourth differential, we are going to get 16 e exponent 2x. We find the fifth differential, 1, 2, 3, 4, 5. We are going to get 32, that's 2 times 6, this now gives us 32 e exponent 2x. Now we have to do the same for this. So we differentiate v the first, second, third up to the fifth time. So v prime, that means the first differential of cos 3x. So whenever we try differentiating a trigonometric function, cosine trigonometric function, what we do is that we differentiate the function here, that's the 3x. So we differentiate 3x, the answer we have is 3. Now, whenever I differentiate cos, the answer is negative sign. So put that negative here, then sine 3x. So that's the answer for the differential of cos 3x. Now, we do that the second time. So we have to differentiate negative 3 sine 3x. So we differentiate, we said that we begin by differentiating the 3x, and that will give us 3. So 3 times 3 will give 3 times 3 is 9. So negative 9. When we differentiate cos, when we differentiate sine, we have cos. So we repeat that. So we find the third one. So the third one, we do the same to differentiate what we have in the bracket. So we differentiate 3x, we have 3. 3 times 9, 9 times 3, 27. So 27. But then whenever I differentiate cos, we have negative sign. So that negative cancels out to the negative here to give us positive 27 sine 3x. Now we do it for the fourth time. So for the fourth time, we have to do the same thing. So 3 times 27, that's 81 cos 3x. Now we do it for the fifth one. That means we have to differentiate cos. So differentiate cos, we have negative sign. So negative 3 times 81. So 3 times 81, that is 243. So negative 243 sine 3x. So when you are done doing this, it means you are halfway through the whole solution process. So now what we have to do is that we need to write the expression for the fifth differential of e exponent 2x cos 3x. So how do we write that? So according to Leibnitz theorem, the fifth differential with respect to x of e exponent 2x of 3x is written as 5 combination 0. So 5 combination 0. Then what you do is that when you take e, you match e to the last differential of v. That's what we do. So 5 combination 0 u times v prime 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 prime. That's the fifth differential. We add that to 5 combination 1. Then now you move a step ahead. So you now come to the second one. So when we take this, then that's the third differential of this. We match it to the fourth differential of v. So that will be written as u prime v prime 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 plus we do same for this guy. So we take the second differential of u and we match it to the third differential of v. So the second differential of u, then the combination below the subscript here will be increasing by 1. So from 0 to 1, we go to 2. So 5 combination 2, u prime prime, v prime prime prime. So we continue plus 5 combination 3, u prime prime. Just make sure that whenever you add this, you have an exponent. It's more like having an exponent of 0. So when you add this 0 to the 5, make sure that whenever you add the exponent, you are getting 5. So 2 plus 3 is 5 plus 5 combination 4, u. There was u prime prime. So this must increase by 1 and this decrease by 2. So this 1, 2, 3, 4. This will give us 1 plus 5 combination 5. That is going to be u 1, 2, 3, 4, 5. Then v. So this is the formula we are going to use to find the fifth differential of it. So let's move on. So we need to find 5 combination 0. So 5 combination 0, that is 1. So 1 times u. So u is e exponent 2x. Then the fifth differential of v from here is negative 243 sine 3x. So negative 243 sine 3x. Then we add that to 5 combination 1. And 5 combination 1 is 5. So 5 times u prime. That's the second one here. So 2 e exponent 2x. Then the fourth differential of v, that is 81 cos 3x. Now we add that to 5 combination 2. So 5 combination 2 is 10. U prime prime, that's the second differential of u, which is 4 e exponent 2x times the third differential of v, that is 27 sine 3x. Plus, we go to this, that's 5 combination 3. So 5 combination 3 is also 10. So 10, we take the third differential of u, that's 8 e exponent 2x times the second differential of v, that is negative 9 cos 3x. Plus, we are done with this. We are moving to 5 combination 4. So 5 combination 4 is 5. We take the fourth differential of u, that is 16 e exponent 2x. We multiply that by v prime, that's the first differential of v. That will give us negative 3 sine 3x. We add that finally to 5 combination 5, which is 1. 1 times the fifth differential of u. The fifth differential of u, which is 32 e exponent 2x times v. That is cos 3x. So if you are able to safely do this, it means you are done with it. The next thing you have to do is that you need to multiply through all of that. You need to expand the terms, you multiply through, then you just break it up. So let's quickly do that. So this time that we are going to have negative 243 e exponent 2x sine 3x. Whenever we have a trigonometric function and then Euler's form present, we always write the Euler's form first before we write the trigonometric form. So this is what we are going to get, plus 5 times 2 times 81. So 5 times 2 times 81, that is 810. So 810 yes, and 2x plus 3x plus, so we are done with this, we are done with this, we are here. So 10 times 4, 10 times 4 plus 10 times 4 times 27. So times 27. 10 times 4 times 27 is positive 27. So that's 1080, 1080 yes, and 2x sine 3x plus 10 times 8 times negative 9, so 10 times 8 times negative 9, that is negative 720. So negative 720 yes, and 2x plus 3x. We add that to, so we are done with this, we are here now. So we add that to 5 times 16, 5 times 16 times negative 3 times negative 3, that's negative 240. So let me write that here. So negative 240, where is that? So negative 240 sine 3x. Then finally, we solve this, which is 32 yes, and 2x plus 3. And we are done. So this is the answer for the fifth differential of e exponent 2x plus 3x using Leibnitz theorem. So it's a very simple theorem. The first thing you need to do is that you break this down into the power of the differential they expect you to do. Then you match first to last, second to last till you are done. Then you match them with the corresponding combinations. Then at the end you just finish. So that is it. Thank you very much for your time. You can stay tuned for more educational videos. And all the best to you. Bye bye. Take care.